Hello and welcome to the mind map for Year 7 Physics, which is on forces. Here's a picture of the full mind map and we're about to zoom on in. A force is an interaction between two objects. A force can be a push, a pull, or a twist. The units are in Newton with the symbol N, and they're measured with a Newton meter, otherwise known as a spring balance. There are two types of measurements for forces: scalar, which is just magnitude or the size of the force, and vector, which is magnitude and direction. Forces can be balanced or unbalanced, and forces can be contact or non-contact. And the diagram there shows the difference between vector and scalar. Speed is scalar, which is just magnitude, like 10 meters per second, and velocity is a vector, which is 10 meters per second forward. All right, balanced versus unbalanced. Forces come in pairs. Every force has an equal and opposite force. Balanced forces cancel each other out, and the vectors are equal and opposite. When forces are balanced, the object is either stationary or maintaining a constant speed. Unbalanced forces are unevenly matched. The vectors are not equal, but are still opposite. When the forces are unbalanced, the object is either accelerating or changing direction. For now, we're going to look at the forces affecting cars, boats, and planes. We'll start with cars. So the upwards force is called the normal, or the normal force. Downwards is weight or gravity. Thrust is propelling it forward, and drag is resisting the motion. For a boat, buoyancy is pushing up, weight is pushing down, drag is pulling it backwards, and thrust is pushing it forwards. For a plane, we've got lift pushing it upwards, weight pulling it down, thrust pushing it forward, and drag pulling it backwards. In the diagram off to the left, we see a car that's got a backwards force of 500 newtons and a forwards force of 500 newtons. So this car is either traveling at the same speed or stationary. And the car below it has 500 pulling it back, 600 newtons pushing it forward. So this car is either accelerating or changing direction. Next, we've got contact versus non-contact. Contact forces require physical contact and non-contact doesn't, or they work at a distance. So the contact forces are friction, which is a restrictive force or a force against motion. Normal force pushes from the ground upwards. Tension force is applied to a rope when it's pulled tight, and applied force is when one object hits another. Non-contact forces are gravity, which is a force of any mass pulling other things towards its center. We've got electromagnetic force, which is between positive and negatively charged objects. Nuclear force holds a nucleus together, and magnetic force is the force between the north and south poles. No force is both contact and non-contact. They have to be one or the other. Now we're going to look at the contact forces. The first one is friction. Friction is delivered by any medium with matter. The force of friction can be reduced by lubricants or streamlining. Friction includes air resistance and drag. Sometimes friction can be useful, like for heat generation or braking in your car, and sometimes it's unwanted when it's opposing the motion that you want. Normal force is the force exerted by the surface. It is perpendicular to the surface. Perpendicular means at an angle of 90 degrees or straight up. Normal force equals the weight of an object. Applied force is the force exerted by one object on another. The applied force can be in any direction and in any strength. The applied force is used to change the direction of motion of the object. Now we move on to non-contact forces. The first one is gravitational force. Any object with mass exerts a gravitational force on nearby objects. The bigger the mass, the bigger the gravity, or the bigger the gravitational force. Gravity pulls objects towards the center of the object. Planets are kept in orbit by gravitational force, inertia, and then the balance between them. So the planets are kept in their orbit by the gravitational pull of the sun on the planets. The planets also have inertia, which is mass times velocity, and the balancing of these two forces allows the planet to stay in orbit. Next is electromagnetic force. Atoms have a positively charged nucleus and negatively charged electrons around it. The electrons can move from one object to another, but the protons in the nucleus cannot move. So, if an electron changes its position from one object to another, the object that it is left becomes positive and the object it is moved to becomes negative. The electrons can be removed by rubbing or friction, and the rules for electromagnetic force are opposites attract and like charges repel. The last non-contact force is magnetic force. Some elements are magnetic, that is iron, nickel, and cobalt. When the domains of an object all face in the same direction, then the object becomes magnetic. The magnetic field of an object likes to align with the Earth's magnetic field. And similar to electromagnetic force, different poles attract and like poles repel. We can make an electromagnet by coiling copper wire around the steel core and then passing a current through it. In this way, you can turn on the magnet with electricity and then turn it off. Okay, now we're going to go on to simple machines. A simple machine supplies a mechanical advantage. Mechanical advantage equals the force produced divided by the force supplied. And there are several different types. The first one is an inclined plane, also known as a ramp. By increasing the distance, we decrease the effort required, or the force has to move along a greater distance. The force moves the load along the ramp. Screws and wedges are types of inclined plane. Then we come to levers. Levers amplify force. And there are three components to a lever. There is the fulcrum, which is the turning point. The load is the object to be moved, and the effort is the applied force. First-class lever has the load, then the fulcrum, then the effort. An example is a seesaw. A second-class lever has the fulcrum, the load, and the effort, and the example is a wheelbarrow. And a third-class lever has load, effort, then fulcrum. An example there is tongs or a shovel. Here's my way of remembering the first, second, and third-class levers. Leafy, flea, leaf. So first class is LFE, second is FLE, and third class is LEF. Leafy, flea, leaf. The next one is the wheel and axle. The wheel spins in a balanced circle around an axle. That means the wheel can't be lopsided. The axle is the rod running through the wheel. It reduces force by reducing friction on the surface. The mechanical advantage is a low input but high output. It can be either a force multiplier or a speed multiplier. If it's a force multiplier, the applied force on the wheel results in more force at the axle. If it's a speed multiplier, the applied force is at the axle and results in more speed in the wheel. Then we have gears. Now gears have to come in pairs for them to be gears. There is the driving gear, which has the applied force, and has the driven gear, which is the output force. A gear is any wheel with teeth or cogs, and a drivetrain is gears that are meshed together. A gear ratio is the ratio of teeth of the meshed gears. When a driving gear moves, the driven gear rotates in the opposite direction. And again, it can be a force multiplier or a speed multiplier. When it's a force multiplier, we've got a small driving gear and a large driven gear. And when it's a speed multiplier, we've got a large driving gear and a smaller driven gear. My diagram on the right-hand side points this out. Next, we've got pulleys. A pulley is a rope running through a groove on a wheel and axle. It is a force multiplier at a distance disadvantage. That means the longer the rope, the less effort that's required. When there's one pulley, it only changes the direction of the effort. And it's easier to pull down than pull up. 2 pulleys halves the effort. 3 pulleys makes the effort a third. And 4 pulleys, you only need a quarter of the effort. Then the last bit of this topic is the fact that Indigenous Australians also used simple machines for the 65,000 years before Europeans turned up. For levers, they used a woomera. There's a picture down the bottom here with the dude with the sunglasses on. The woomera increases the distance of the effort and increases the force output. It makes the lever longer. They also used inclined planes in fish traps, and they used slopes to redirect water so they could use it to their best advantage. And the Aborigines also used bifacial wedges as scrapers and cutting tools. And they also used normal wedges to split wood for shelters and remove the bark from trees to make canoes. And here's a diagram of a bark canoe created by the Aborigines. Then we've got the inclined plane to make a fish trap. As I said before, we've got this young man with the sunglasses on using a woomera to make his spear throwing more effective and more powerful. All right, thank you for listening. I hope you enjoyed it. I hope you've learned something. Please consider liking and subscribing, and I'll catch you later. Bye now.